For example number 3, part C, we want to verify that 2 cosecant squared alpha is equal to 1 divided by 1 minus cosine alpha plus 1 divided by 1 plus cosine alpha. We're going to call the right-hand side of the equation the more complicated side of the equation just because it has 2 fractions in it. So combining them, turning them into a single expression like on the left-hand side is going to be easier than decomposing the cosecant squared into these 2 terms. All right, so the first thing that we're going to do here is, because again we want to combine these 2 fractions, we want to turn these 2 terms into a single term as we have on the left-hand side, is we have to ask ourselves, what is the LCD? So I have 1 factor 1 minus cosine alpha, 1 factor 1 plus cosine alpha. So the LCD is going to be 1 minus cosine alpha times 1 plus cosine alpha. And let's multiply each term in our numerator by the missing factor. Well, to get from 1 minus cosine alpha to 1 minus cosine alpha, 1 plus cosine alpha, we had to introduce a factor 1 plus cosine alpha. To get from 1 divided by 1 plus cosine alpha to 1 minus cosine alpha, 1 plus cosine alpha, we had to introduce a factor of 1 minus cosine alpha. Okay, so distributing in, we have in the numerator, we have 1 plus 1 cosine alpha, plus for the first term, and then we have 1 times 1 minus cosine alpha, which is the same thing as saying 1 minus 1 cosine alpha. Notice what happened in the numerator. These factors, or these terms, the 1 cosine alpha minus 1 cosine alpha, are going to cancel, and we're left with 2 divided by 1 minus cosine alpha times 1 plus cosine alpha. Okay, very exciting. You know why I'm excited? You see the 2? You see the 2? That means we're on the right track. Okay, and again, the idea is, let me bring this down with it, 2 cosecant squared alpha. The idea is we want to turn this right-hand side into the left-hand side. And we have a single term on the left-hand side, so we're going to FOIL out the denominator in hopes of finding some type of identity or some type of way for us to reduce it. FOIL because it's a binomial times a binomial. So 1 times 1 is 1. 1 times cosine alpha is plus cosine alpha. Negative cosine alpha times 1 is minus cosine alpha. Negative cosine alpha times cosine alpha is minus cosine squared alpha. Okay, in regards to canceling out terms that are the same, we can cancel out this cosine alpha and this minus cosine alpha. And now we have the following. We have 2 divided by 1 minus cosine squared alpha. Think about that. I've talked a lot about this idea of anytime you see squared terms with 1s in it, then you can think about the Pythagorean identities. And the first Pythagorean identity told us sine squared plus cosine squared is equal to 1. This is 1 minus cosine squared. So if we subtracted cosine squared from both sides of this, then that's the same thing as saying that sine squared alpha is equal to 1 minus cosine squared alpha. Here's what we can do. This 1 minus cosine squared alpha, we can substitute in sine squared for it. So this is the same thing as saying 2 divided by sine squared alpha. And what is the reciprocal of sine? You got it. The reciprocal of sine is cosecant squared. So this is the same thing as saying this. And that's the same thing as saying. And so, ladies and gentlemen, it has been shown, it has been verified.